The AM Express team is pleased to present our entry to the December 2016 OpenWERX Challenge, Seal the Gap, Boat Bow Bumper. I'd like to begin by introducing our team. I'm Darrell Wallace, Project Lead and Engineer. I'm President of Assimilogic LLC, a consulting company providing innovative technology-based problem solutions to manufacturers. I helped establish America Makes, the National Additive Manufacturing Innovation Institute, the first of the U.S. National Manufacturing Institutes. There I served as the founding Deputy Director for Workforce and Educational Outreach. I later served as the Deputy Director for Advanced Manufacturing Enterprise. I bring perspectives to the team from more than 25 years of manufacturing experience across a wide range of sectors. Skip Parrish is our team's systems integration expert and concept originator. Skip is the CTO of Unmanned Aerial Technologies Proprietary Limited. Skip brings to the team a rich background in defense applications. He provides advisory support to TRADOC and NATO in the areas of cyber warfare and energy weapons. He holds patents on new defense technologies, including IED detection. He's a frequent lecturer on topics related to energy weapons and asymmetric warfare. He also serves as a civilian subject matter expert in support of the SOCOM Wide Mission Support Group B contract. Program management for the AM Express team is provided by Rich Leonardo, Principal of Defense and Energy Systems. Rich assists with technology transition and program management for industrial, nonprofit, and defense clients. He is currently supporting the integration of additive manufacturing technology and training into the U.S. industrial base, the defense sustainment sector, and SOCOM. Rich's past military assignments include science advisor positions in Southcom and CENTCOM, as well as multiple deployments in the Gulf War and Iraq. We summarize our problem statement as follows. We are to develop a system to provide safe, balanced transport of operator personnel from the host vessel to the target vessel by way of the host vessel bow. The device must be removable and must protect the host vessel bow from impact damage. The details of the challenge included additional application specifications. Those included that the device must accommodate single file personnel. It must be able to be deployed by one person in under 5 minutes, at night and in 4 to 6 foot swells. The device must be able to be stored in a 4 foot by 4 foot by 2 foot storage compartment. The device can be attached to the vessel by any of 3 suggested attachment points, each with a maximum of 3,000 pound load capacity. If power is required, there is 24 volts DC and compressed air available. A dynamic load of 1,000 pounds is expected in 1 second increments, and a static thrust load of 5,000 pounds is expected during thrust. Based on the information provided, the team attempted to make further inference about the use case for this device. First, rapid boarding operations to be conducted at night. The bumper device will be placed on the bow of the assault boat prior to engagement. The host vessel will impact the target vessel with a force of up to 1,000 pounds. Once the 2 vessels come into static contact, the assault craft will throttle into the target vessel with up to 5,000 pounds of sustained thrust to ensure stable engagement. Operators will then rapidly proceed out over the bumper device and onto the target vessel without the need for lines exchanged between the vessels. Using an inflatable or rigid inflatable boat, a conventional boarding party might come alongside in a similar manner to what is pictured here. Based on the limited information that was provided, it appears that the operator vessel is a rigid hull vessel not suited for dynamic hull-to-hull contact, as would be expected in a boarding operation. Given the unique characteristics of the bow section of the host vessel, the AM Express team believes that the host vessel in question is closely related to this boat found in Dayton, Ohio. The vessel is identified as Halter Marine HSAC Mark Mod II high-speed assault craft. It has a 39-foot length, 9-foot beam, a shallow 3-foot draft, and is constructed of high-strength composite. The photos shown here show the operation of the 4-foot stowage compartment sliding down and into the hull as described in the FAQ for this challenge. The forward compartment is identified as a small powered weapons bay. Such a craft with its low freeboard and hard sides would easily be damaged during the boarding operation. Thus, it is inferred that the intent of this challenge is an application such as pictured here. The device is mounted to the bow of the assault craft. The vessel is then driven into the target vessel perpendicular to broadsides, providing solid contact and a platform from which to board the target vessel. Serving that purpose, the AM Express team proposes a device that attaches to the bow, protects that bow from impact with the target vessel, and facilitates boarding. This design is principally comprised of three components. In direct contact with the host vessel is a foam liner that cushions and protects the hull of the host vessel. The liner is assembled from water-jet cut, 1-inch thick nitrile foam pads rated at 213 psi at 50% deflection. Under full load, if the frontal impact is distributed across 150 square inches of projected surface, the resulting load on the bow will average out to just 33 pounds per square inch of projected surface. The foam liner is bonded to a sturdy aluminum plate frame that distributes the load evenly across the bow of the boat. The frame also serves as a structural decking across which the operator personnel may traverse. Mounted to the outside of the aluminum frame is a custom bumper. The front of that bumper has a curved face that is intended to distribute the load across a range of angles of attack. It curves to the bottom in anticipation of the bow rise that will be expected under high thrust, and the induced angle that will occur as a result of ocean swells. The construction of this bumper could be achieved by several means. It may be a molded vinyl inflatable structure, as is common for marine fenders. Alternatively, at lower volume production, it might be more cost-effective to fabricate from a dense closed-cell foam such as nitrile or EVA with a subsequent encapsulation in a vinyl shell. Deployment of this device is simple and straightforward. It begins with the fully stowed device below decks. In the first step of the deployment, an operator takes the two tie-down straps attached to the aft portion of the bumper assembly and attaches them to the hard points on the deck. Once both straps are fully secured, the boarding device can be lifted onto the deck and pushed forward until it drops into position over the bow. The attached straps prevent accidental loss of the unit overboard. The concave receiving cavity in the device ensures that once it drops into position and the straps are tightened, the platform is secured. Though the device is fully secured into position with the two initial tie-down straps, a third strap passing through the towing loop on the bow provides redundancy and helps to distribute the impact load during the boarding operation. To install this strap, the operator will crawl onto the bow, lay down on the platform, and pass a tie-down strap to connect from the attachment points on the port and starboard sides of the platform through the towing loop. He will then fully tighten the bow tie-down strap. To complete the installation, the operator should ensure all tie-down straps are now fully tightened. Total installation time for this device would be expected to be less than 3 minutes under normal circumstances. The challenge documents did not specify the circumstances under which the device might be ordered. The primary design presented can be fabricated cost-effectively on short lead times and at small order quantities. Depending on quantity to be ordered or circumstances under which the device is to be produced, alternative designs might prove to be advantageous from a design for manufacturability standpoint. Two such alternative manufacturing methods are offered for the basic design that has been presented. The first utilizes the same metallic frame to provide structure to the boarding device. That frame then has a low durometer thermoplastic elastomer shell overmolded onto it. TPE is very tough and is commonly used for impact absorption applications such as traffic safety barriers, bridge expansion joints, and tractor-trailer dock cushions. Though likely to be somewhat heavier, the molded design would create a nearly indestructible one-piece device with integral cushioning sections molded in and a complete covering of non-slip, non-reflective material. The design concept that is presented might also be adapted as to be able to be printed on a large format 3D printer. The platform could be produced from a single high-strength material, such as Ultem 9085, or could be made from a hybrid composition of structural and shock-absorbing materials. Shock-absorbing capabilities would be achieved through integral living spring structures, and without the need for tool production, the device could be printed on demand and on an as-needed basis. The ability to print the device on demand and as needed opens the possibility that it could be delivered to the point of use electronically and then printed in the field on a forward deployed 3D printer. The design of the part could even be specifically tailored to the mission as appropriate. We believe that the concept we propose offers a simple, robust solution that meets the requirements of the challenge, providing a means to traverse between vessels in the boarding situation described. The device stows fully assembled in a space of just 48 by 32 by 16 inches. From fully stowed, it is expected that the device can be deployed in under 3 minutes by just one person. On behalf of the AM Express team, we thank you for your consideration. Our contact information is provided here should you wish to follow up with us on any questions.